Alright, in this video, we'll be solving the CIE A-Level Maths 9709, paper 33 for October 2024. If you're feeling anxious, overwhelmed, or unsure where to start, then I've created a complete course that streamlines everything with step-by-step videos, interactive quizzes, and an exclusive student community to keep you on track. You can get access to it by clicking the first link in the description. Otherwise, like the video, subscribe, and let's dive right in. Question number 1. Complex number z satisfies the modulus of z is equal to 2 and arg z is between 0 and a quarter pi. Part A. On the Hagen diagram below, sketch the locus of the points representing z. So let's start with this equation here. The modulus of z is equal to 2. So this is a circle, and since they haven't given us a complex number inside, this is essentially z minus 0 plus 0i. Okay, and this is equal to 2. So it's a circle with the center 0, 0. So our center is here, and then our radius is going to be 2. So let's draw that we've got a circle like that. Let me see if I can get it bang in the middle. Maybe a little bit left, slightly somewhere here. I think that's decent enough. And this should be 2 units. And this should also be 2 units because our circle has radius 2. Okay. And then we also want arg z to be between 0 and a quarter pi. Alright, so if you convert a quarter pi to degrees, that's going to be 45 degrees. If you use your protractor to open up an angle of 45 degrees, you should find that it's bang in the middle of your axis. And so it's going to look something like that. And so essentially this angle is a quarter pi. And so we want points that satisfy both inequalities. So they have to be on the circumference of the circle, and the angle should be less than or equal to a quarter pi, but also greater than or equal to 0. So I'm going to shade that. So I'm going to highlight that in red. So it's going to start at this point on the circumference. Here our arg z is going to be equal to 0, and we go all the way up to a quarter pi, and this is where we would stop. So the locus of points representing z would be all the points that lie on the red arc. Everything else does not satisfy z, because we're saying that our argument has to be between 0 and a quarter pi. So 0 starts here and goes all the way up to a quarter pi here. And this part is saying that the points have to be on the circumference. That's why we're only taking points that are on the circumference. Then part B says, on the same diagram, sketch the locus of the points representing z squared. Okay, so let's start with the first equation that we have. The modulus of z is equal to 2, but now we want to do it for z squared, so replace z with z squared. So we're looking at the modulus for z squared. What is it now going to equal to? This, we know that this should be equal to, this is the same as the modulus of z times z. So it's going to be equal to the modulus of z times the modulus of z. So essentially the modulus of z squared is just equal to, that's 2 times 2, because the modulus of z is 2. 2 times 2. So the modulus of z squared is 4. So the loci of z squared, I'll represent them in green. So this means that this is a circle again with center 0, 0, and its radius is going to be 4. Okay, so it should look something like this. Right. And this here would be 4 units, and this is also 4 units. And now for the argument, we're going to say for the argument of z squared, this is essentially the same as arg z times z. And we know that our arguments behave similarly to logarithms. So I can write this as arg z plus arg z. So this means that, in other words, arg z squared is equal to 2 arg z, or 2 arg z, 2 arg z. Okay. So for z, we had that arg z or arg z is between 0 and a quarter pi. Once we move to z squared, this angle here is going to be 2 times arg z, so it's still going to be 0. And then this angle here is 2 times a quarter pi, so now that angle becomes 1 over 2 pi. Okay, so it means for z squared, we want the angle, we want to open up an angle of half pi. If I go back to my green pen, that's essentially just along the imaginary axis. So moving along like this. And so I'll highlight the points that we want. So we want points that are on the circumference of the green circle but have an angle but are below half pi but still above 0. So we want this arc over here. So on the bigger arc, those are the loci for z squared, and on the smaller arc, this one inside, that's the loci for z. Number 2, let f of x equal 2x cubed minus 5x squared plus 4. Show that if a sequence of values given by the iterative formula xn plus 1 is equal to root 4 over 5 minus 2xn converges, then it converges to a root of the equation f of x is equal to 0. Okay. So f of x is equal to 0 would be 2x cubed minus 5x squared plus 4 is equal to 0. Essentially, what they want us to do is to show that this equation is the same as that equation. So let's do that. I'm just going to remove the n plus 1 and the n's, so that x is equal to the square root of 4 over 5 minus 2x. Okay. And so we can start off by just squaring both sides to get rid of our square root. So you get x squared is equal to, that's 4 over 5 minus 2x. Then I'm going to multiply both sides by 5 minus 2x to get rid of our denominator. So we end up with x squared times 5 minus 2x is equal to 4. Expand the bracket, that's 5x squared minus 2x cubed, and this is equal to 4. Then I'm just going to move everything to the right hand side, so we end up with 2x cubed minus 5x squared plus 4 is equal to 0, and that is exactly this equation over here. So we have shown that if our iterative formula converges, then it converges to a root of the equation f of x is 0. Part B says the equation has a root close to 1.2. Use the iterative formula from part A and an initial value of 1.2 to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Alright, so we've been given that x0 should be 1.2. So we can carry out our first iteration x1. That's going to be the square root of 4 over 5 minus 2 times 1.2. And this is approximately equal to, let's punch this into the calculator, 4 over 5 minus 2 times 1.2. That gives us, they want it correct to 4 decimal places, so 1.2403. Okay. And let's move on to the next iteration, x2. So that's going to be the square root of 4 over 5 minus 2. And here I'm going to use a function on your calculator, which is the answer function, usually written ANS, which stores the result of the previous calculation. So I'm just going to use that. I will replace the 1.2 with ANS, and then I press equals. So essentially what it's doing in this case is it stores the result of each previous iteration so that you don't have to keep substituting in the result of the previous iteration. Okay, so that's 1.2601. And again, you're going to leave it in your calculator exactly as this expression and simply press equals to get the result of the third iteration. That would be 1.2700. Don't change anything in your calculator, press equals. That's 1.2752. We're not yet there. Press equals. That's 1.2778. We have arrived. This is approximately 1.28, and this is also 1.28. So our root has converged. So you can say that therefore the root is 1.28, and that is our final answer. Number 3. The number of bacteria in a population P at time t hours is modeled by the equation P is equal AE to the KT, where A and K are constants. The graph of ln P against T shown in the diagram is gradient 1/20 and intersects the vertical axis at 0, 3. State the value of K and find the value of A correct to two significant figures. Okay, so here they've got a line of ln P against T. So to clearly see that line in the form y equals mx plus c, we can start off with that relationship and we want to rewrite it or reduce it to a linear form. So we're going to apply the natural logarithm to both sides. So we've got ln P is equal to that ln A plus ln e to the kt. So ln P is equal to ln A plus ln and e will cancel out, so you end up with kt. So what you have is ln P is equal to kt plus ln A. All right, and notice how this resembles the equation of a straight line. Y is equal to mx plus c. On your y-axis, you've got ln P. That's going to be your y. On your x-axis, you've got a t. So it means your ln P is your y, and then your t is your x. So therefore, k must be the gradient of this line, m, and then ln A must be the y-intercept. So they're saying state the value of k. We've been given the gradient of this line. So k must be the gradient, k must be 1/20. And then we also have to find a correct to two significant figures. Here we can tell that ln A must be the y-intercept. So this means that ln A must be equal to our y-intercept here is 3. So if we apply the exponential function to both sides to cancel out that ln, we end up with A is e to the 3. You punch that into the calculator, that gives you, that's 20.086. They want their answer correct to two significant figures. So k is 1/20 and a is 20 correct to two significant figures. Part B says find the time taken for P to double, give your answer correct to the nearest hour. Okay, so when we reduced this equation to linear form, we say that it's going to be of the form ln P is equal to k, which we said is 1/20, and this is multiplied by t plus ln A. Ln A we found to be, ln A was 3. So this is plus 3. Okay, oh, ln A is right over here, plus 3. And so they're saying find the time taken for P to double. All right, what is P anyways? P is the number of bacteria in a population P. So initially we're saying that ln P is equal to, that's 3. So that means that our P, if we take the exponential of both sides, that means initially P is equal to 3. So they're saying find the time taken for this value to become double. So in other words, for this to become 2e cubed. So what we can do is to simply substitute p with 2e cubed into our equation, and then we solve for t, because t represents the time taken. So that's going to be ln 2e cubed is equal to 1 over 20 t plus 3. So we can write this as that's ln 2 plus ln e cubed, using laws of logarithms. Since these are multiplying, they add if we separate them. So 1 over 20t plus 3. This here cancels out, so you've got ln 2 plus 3 is equal to 1 over 20t plus 3. And so let's subtract 3 from both sides. You end up with ln 2 is equal to 1 over 20t. Multiply both sides by 20. You get t is equal to 20 ln 2. They want it correct to the nearest hour. So if we punch this into the calculator, this is 20 ln 2 is equal to, so t is equal to 13.863. So to the nearest hour, that's going to be 14 hours. Okay, and that's our final answer. Number 4, find the complex number z satisfying the equation z minus 3i over z plus 3i is equal to 2 minus 9i over 5. Give your answer in the form x plus iy, where x and y are real. Alright, so z is of the form x plus iy. So we can replace z with x plus iy. So this becomes x plus iy minus 3i, and this is over x plus iy plus 3i. This is equal to 2 minus 9i over 5. So let's cross multiply. So we end up with 5 times x plus iy minus 3i is equal to 2 minus 9i times x plus iy plus 3i. Okay. So before we expand, I just want to group the imaginary parts here. So that's x plus, and in brackets, that's going to be y minus 3i. Okay. And this is equal to 2 minus 9i x plus y plus 3i. All right. So now let's expand. 5 times x gives us 5x, then 5 times y minus 3i, that's going to be plus 5 times y minus 3i. In fact, I think I'm going to multiply through with the 5 inside of the bracket, so that is 5y minus 15. So 5y minus 15i, and this is equal to, we're going to do, that's 2 times x, 2x, 2 times y plus 3 plus I, so that gives us 2y plus 6i, and then we've got negative 9i times x, so negative 9xi, and then negative 9 times, and then negative 9i times y plus 3i, so that's negative 9 y plus 3, and then I times I, so I squared. So this is 5x plus 5y minus 15. I is equal to, and then here we've got 2x. And remember that I squared is equal to negative 1. So this part essentially becomes positive 9y plus 3. So positive 9y plus 3. And then we've got the imaginary part, which becomes 2y plus 6 minus 9xi. So this is 5x plus 5y minus 15i is equal to 2x multiplied through by 9, that is 9y plus 9 times 3, which is 27. And then we've got our imaginary part, 2y plus 6 minus 9xi. And then two complex numbers are equal if and only if both the real and imaginary parts are equal. So we can equate the real part on either side. So that's 5x is equal to 2x plus 9y plus 27. And we can equate the imaginary parts. So 5y minus 15 is equal to 2y plus 6 minus 9x. 2y plus 6 minus 9x. All right. And now we've got two equations in terms of x and y. So let's make x the subject of the formula in this first equation. So that's 5x minus 2x, which gives us 3x, is equal to 9y plus 27. Divide through by 3, x is equal to 3y plus 9. So we can replace this x here with 3y plus 9. Let's do it on the side. So 5y minus 15 is equal to 2y plus 6 minus 9 times our x, which is 3y plus 9. 3y plus 9. So we've got 5y minus 15 is equal to 2y plus 6 minus 9 times 3y, that gives us minus 27y, minus 9 times 9, that gives us minus 81. So this is 5y minus 15 is equal to 2y minus 27y, that's minus 25y. And we've got 6 minus 81, that's minus 75. Let's put all the terms in y on one side, so 5y plus 25y is equal to negative 75 plus 15. This gives us that 30y is equal to, that's negative 60. Divide both sides by 30, you get that y is negative 2. So if y is negative 2, it means that our x, which is 3y plus 9, is going to be 3 times negative 2 plus 9. So x is negative 6 plus 9, which is positive 3. So we can conclude that therefore our answer, remember, it's of the form x plus iy, so it's 3 minus 2i. Number 5, part A. Show that cos to the 4 theta minus sine to the 4 theta minus 4 sine squared cos squared is identical to cos squared 2 theta plus cos 2 theta minus 1. I think here we're going to work from the left-hand side moving to the right-hand side. So that's cos to the 4 theta minus sine to the 4 theta minus 4 sine squared theta cos squared theta. And the first thing that I'm seeing here is we've got a difference of two squares. So a difference of two squares is anything of the form a squared minus b squared. And this can be factorized to a minus b times a plus b. So in this case, we've got cos squared theta squared. So essentially cos squared theta is the a minus sine squared theta squared. So b is sine squared theta. So this should factorize to cos squared theta minus sine squared theta times cos squared theta plus sine squared theta. Alright, so I'm going to write it here. That is cos squared theta minus sine squared theta times cos squared theta plus sine squared theta minus our 4 sine squared cos squared, 4 sine squared theta cos squared theta. Okay, so this here, using an identity, can be written as cos 2 theta. This is identical to cos squared theta minus sine squared theta. So this becomes cos 2 theta. And then this part here, cos squared theta plus sine squared theta. Cos squared theta plus sine squared theta is identical to 1. So we're just multiplying by 1 there, and we've got minus 4 sine squared theta cos squared theta. So this is cos 2 theta minus 4 sine squared theta cos squared theta. So we've got the cos 2 theta part. So somehow this part is supposed to generate cos squared 2 theta minus 1. And I am noticing similarities with the identity or the double angle formula for sine 2 theta, which can be written as 2 sine theta cos theta. So notice how this can be written as minus 2 squared sine squared theta cos squared theta. Just put the cos 2 theta there. So essentially we can sort of factor out this power 2 so that it's cos 2 theta minus, in brackets, it's 2 sine theta cos theta, and everything is all squared like this. And as a result, we can replace this 2 sine theta cos theta with sine 2 theta. So what we have is cos 2 theta minus, in brackets, we've got our sine 2 theta, and this is squared. And so this is cos 2 theta minus sine squared 2 theta. And somehow from sine squared 2 theta, we're supposed to come up with cos squared 2 theta minus 1. Okay. So what we could do is, we know that sine squared theta plus cos squared theta is identical to 1. So if we just change the angles to 2 theta, because that would help us come up with a relationship between sine squared 2 theta and cos squared 2 theta. This would be sine squared 2 theta plus cos squared 2 theta, and this is equal to 1. And so I want to rewrite sine squared 2 theta, so we'll make it subject of the formula. This would be 1 minus cos squared 2 theta. And so replace sine squared 2 theta with 1 minus cos squared 2 theta. So that's cos 2 theta minus, and then in brackets we've got our 1 minus cos squared 2 theta. So 1 minus cos squared 2 theta, which gives us cos 2 theta minus 1 plus cos squared 2 theta 2 theta. I believe if we write it in order, that's what they want. Cos squared 2 theta plus cos 2 theta minus 1. Yes, cos squared 2 theta plus cos 2 theta minus 1. So we have proved the identity that, what is our identity? Cos to the 4 theta minus sine to the 4 theta. Is it minus again? Minus 4 sine squared minus 4 sine squared theta cos squared theta is identical to cos squared 2 theta plus cos 2 theta minus 1. Alright, that's the proof. Part B says solve the equation cos to the 4 alpha minus sine to the 4 alpha is equal to 4 sine squared alpha cos squared alpha. Okay, so this is essentially cos to the 4 alpha minus sine to the 4 alpha. Let's move this to the left. That's minus 4 sine squared alpha cos squared alpha, and this would be equal to 0. Notice how this expression is pretty much our identity from over here. It's the left hand side of our identity. So we can rewrite this using the right hand side, and they've just replaced theta with alpha. So what you would get is cos squared 2 alpha plus cos 2 alpha minus 1, and this is equal to 0. And we're solving for alpha is between 0 and 180 degrees. Alright, let's use the quadratic formula. This is a quadratic in cos 2 alpha. Our b is the coefficient of cos 2 alpha, so that's minus 1 plus or minus the square root of b squared 1 squared minus 4 times a times -1, and this is all over. This is 2 times 1. Punch that into the calculator. That is -1 plus the square root of 1 squared minus 4 times 1 times -1, and this is over 2. That gives us -1 plus or minus the square root of 5 over 2. All right. So either cos 2 alpha is equal to -1 negative root 5 over 2, or that cos 2 alpha is equal to -1 plus root 5 over 2. And so let's solve each equation separately. Here we get that 2 alpha is arc cos of -1 negative root 5 over 2, and we are in degrees. So our principal value here, PV, is equal to, make sure your calculator is in degrees, that's arc cos of -1 negative root 5 over 2, and that gives us an error. So here we get alpha is no solutions. I'm assuming this is because this number is smaller than -1. Let's just check. Negative root 5 over 2. Yes. So if you look at the graph of y equals cos x, what we're looking at is something like this. And this here is 1, and this is -1. So our value here is approximately -1.6. So it would be somewhere here. As you can see, this value is not going to intersect our graph at all. So as a result, there would be no solutions. So we just write here alpha, there's no solutions. Let's evaluate the other one. That's going to be 2 alpha is equal to arc cos of -1 plus root 5 over 2. So 2 alpha, or in fact the principal value, is equal to, this is arc cos of -1 plus root 5 over 2, and this gives us 51.82729,237. All right. And what is our interval? Our interval is from 0 to 180 degrees. But I want you to notice that our principal value is going to be in terms of 2 alpha. So at the end, we're going to have to divide by 2 to find alpha. It means that here, what we should be looking for is 2 alpha is between what? 0 and 360 degrees. Because when we then divide through by 2, we then get this interval. So using our principal value, we can look for values between 0 and 360. And in fact, what we can do, since I've already drawn the diagram, let's just use that to help us find what we want. First, let's label. This is in degrees, so that's going to be 90 degrees, that's 180. This is 270, and finally we've got 360. So we got a value at 51.8. 51.8 would be somewhere here. That's 51.8. Let's draw a line going through. Okay, so we've got another solution at this point here. And by symmetry, since this distance here is 51.8, it should mean that the distance from 360 all the way to our point here should also be 51.8. So we can say 360 minus 51.8. Just give it more decimal places, and 729. So that's 360 minus 51.827729, which is, and remember this is in terms of PV, so 2 alpha, not theta. We're dealing with alpha. So it's going to be 2 alpha, okay? And that's going to give us 2 alpha is 308.172. Okay, so it means that this value here is 308. 0.172. And as you can see here, these will be the only two solutions within our given interval. So we can conclude that, or not conclude, but we can find the exact value for alpha. So either 2 alpha is our principal value, 51.827. So alpha would be, if we divide it by 2, that's 51.827 divided by 2, 25.9 degrees. Or 2 alpha is equal to 308.172. If we divide it by 2, that's 308.172 divided by 2. This gives us 154.1 degrees. These will be our two answers. Number 6, the lines L and M have vector equations. R is equal to 2i plus j minus 3k plus lambda times negative I plus 2k, and M has equation R is equal to 2i plus j minus 3k plus mu times 2i minus j plus 5k. Part A says lines L and M intersect at the point P. Part A says state the coordinates of P. I'm just going to rewrite these two equations in column vector notation. So R is 2, 1, negative 3 plus lambda times, that's negative 1, 0, 2. And then the other equation is R is, that's 2, 1, negative 3 plus mu times 2, negative 1, 5. Okay. So these are the two equations, and we're told that they intersect, so we can write them in their component form. So that would be 2 plus lambda times negative 1, so 2 minus lambda, 1 times lambda times 0, so that's just 1, and then negative 3 plus 2 times lambda, so negative 3 plus 2 lambda. And then the other component form would be 2 plus 2 mu, 1 plus mu times negative 1, so 1 minus mu, then minus 3 plus 5 times mu, so minus 3 plus 5 mu. Okay, and we can just equate each row. So that's 2 minus lambda is equal to 2 plus 2 mu, 1 is equal to 1 minus mu, and negative 3 plus 2 lambda is equal to negative 3 plus 5 mu. Okay, notice how in the second equation we can easily tell what the value of mu would be. So there we'd get that we've got 1 equals 1 minus mu, so we get that mu is equal to 1 minus 1, so mu is equal to 0. So we know that at the point of intersection the value of mu is equal to 0, and these are the general coordinates for any point that lies on this line, and obviously the point of intersection is going to lie on that line. So we know that at the point of intersection, mu is 0. So this means that, what do they want? They want the coordinates. So we have to be careful. I'm going to first write the position vector OP. Position vector of OP is going to be, that's 2 plus 2 times 0, which is just 2. 1 minus 0, that's just 1. Minus 3 plus 5 times 0, that's just minus 3. Okay. But they say they want coordinates, so don't give this as a vector, give this as coordinates. So that's P is 3, 2, 1, negative 3. So 2, 1, negative 3. Those are the coordinates of P. Part B says find the exact value of the cosine of the acute angle between L and M. Cos theta is going to be equal to the dot product of the directions of L and M divided by the magnitudes of these direction vectors. Okay, so let's start by finding the dot product or the scalar product of the directions of L and M. So this is L, or direction of L rather, dot the direction of M. So the direction of L is right here, that's negative 1, 0, 2. dot, and the direction of m is 2, -1, 5, 2, -1, 5. And so that's -1 times 2, which is -2, plus 0 times -1, so that's 0, plus 2 times 5, so that's 10. And this simply gives us 10 minus 2, which is 8. Okay. Apart from the dot product, we also need to find their magnitudes. So the magnitude of L, or the direction of L rather, is going to be -1 squared plus 0 squared plus 2 squared. So this is 4 plus 1, 5. So that's root 5. And then the magnitude of the direction of m is equal to the square root of 2 squared plus -1 squared plus 5 squared. So that's 25 plus 4, 29 plus 1, 30. What is root 30? That is just root 30. So the magnitude of the direction of m is equal to root 30. And now we can simply just substitute into this formula. We're saying cos theta is equal to 8 divided by root 5 times root 30. And we can write this as cos theta is equal to 8 over the square root of 5 times 30, which is cos theta is equal to 8 over, what is 5 times 30? That is 150. What is the square root of 150? Or rather, what is 8 over root 150? That's going to be 4 over 15. Cos theta is 4 over 15 root 6. And this would be our final answer. Part C says the point A on line L has coordinates 0, 1, 1, and the point B on line M has coordinates 0 to -8. Okay, and they want us to find the exact area of triangle APB. I'm just going to draw a sketch so that we can visualize what's going on. We've got a line L, and we've also got a line M, and we know that these two lines intersect. Okay, and then we've got the point of intersection, by the way, is P, and we've got the point A, which I would say is somewhere here. A lies on line L, so let's say this is A, and then we've got the point, let me write its coordinates as well. We also have the point B, which lies on line M, so B would be, maybe let's put B here, and B has the coordinate 0 to -8. Okay, and we also have the coordinates of P from part A to be 2, 1, -3. So that's 2, 1, -3. And we want the exact area of the triangle APB. So that will be this triangle, A to P, and it comes back to B. Okay. Okay, and we need to find the area of this triangle APB. In part C, we evaluated cosine of what? Cosine of the angle between L and M. Okay, so the angle between L and M, that was going that way, M. So we evaluated this angle. This angle is angle theta. So we know that cos theta from part B is what? Is 4 over 15 root 6. 4 over 15 root 6. The formula we want to use is that area of a triangle is equal to half AB sine C, where A is going to be AP, so this would be A, and then B is BP, B, okay? And C is going to be the angle theta, of course. So we've got two sides, so we've got an angle between these two sides. So if we can find the length of AP and the length of BP, we already know that cos theta is 4 root 6 over 15. So we should be able, in fact, let me just write this as sine theta. So we should be able to find sine theta. So that means this area would be half of the magnitude of the distance from A to P multiplied by the magnitude of the distance from B, which we're saying is B to P. So BP, and of course our sine theta. So we need to find the magnitude of A to P. And we can find that essentially just using the formula x1 minus x2 squared plus y1 minus y2 squared, except now we've got a third coordinate, so you also have to include z1 minus z2 squared. Okay, so the magnitude of AP is going to be equal to, this is the square root of A, we've got 0 minus 2, 0 minus 2 squared plus 1 minus 1 squared plus 1 minus minus 3 squared, so 1 plus 3, and this is squared, so the magnitude of AP is equal to, let's punch this into the calculator. This is the square root of 0 minus 2 squared plus 1 minus 1 squared plus 1 plus 3 squared, and this gives us 2 root 5. And then we also need to find the magnitude of BP. So the magnitude of BP is equal to, this is, again, we're using the same formula. So we want the change in our x. So 0 minus 2 squared plus, we've got 2 minus 1 squared plus, we've got negative 8, negative 3, so negative 8 plus 3 squared. So this means the magnitude of BP is equal to, that is the square root of 0 minus 2 squared plus 2 minus 1 squared plus negative 8 plus 3 squared, which gives us root 30. Okay, so now we've got the magnitude of AP, we've got the magnitude of BP, we need to find sine theta. So here we're saying that cos theta or cosine of theta is equal to 4 root 6 over 15. We can draw a right angled triangle so that we can use this to help us find sine theta. Just make sure that's straight. Okay, so this would be theta. This is the right angled triangle. Remember that cos theta represents your adjacent over your hypotenuse. So the numerator is the adjacent, so that means this is 4 root 6, and that means our hypotenuse is 15. We need to find the opposite. Using Pythagoras, we can say that the opposite is going to be the square root of our hypotenuse squared minus 4 root 6 squared. And so our opposite is going to be, that's the square root of 15 squared minus 4 root 6 squared. And this is root 129. So this means that this here is root 129. We know that our sine theta is equal to the opposite over the hypotenuse. So that means sine theta is going to be our opposite, which is root 129, divided by our hypotenuse, which is 15. So now we've got all the bits and pieces of information that we need to find our area. So the area of a triangle is going to be equal to half times AP, which we say is 2 root 5, 2 root 5 times BP, which is root 30, multiplied by sine theta, which we're saying is root 129 over 15. Okay. All right, so the area of the triangle is equal to, this cancels out. We've got root 5 times root 30 times root 129 over 15. That's root 5 times root 30 times root 129 over 15. And this gives us the square root of 86. And we can conclude that this is our final answer. Number 7, the parametric equations of a curve are x is equal to 3 sine 2t and y is equal to tan t plus cot t, where t is between 0 and half pi. Part A, show that dy dx is equal to negative 2 over 3 sine squared 2t. Alright, so before we look at finding dy dx, let's start by just differentiating both of our parametric equations. So we've got x is equal to 3 sine 2t. Let's find dx dt. So dx dt is going to be equal to, we've got the 3. If you differentiate sine, you get cos. So this is going to be cos 2t. And remember, you also have to differentiate the inner function. You differentiate a 2t, you're going to get 2. So we have to multiply by 2. Okay, so this means dx dt is going to be equal to that 6 cos 2t. Alright, and now we're going to do the same for y equals tan t plus cot t. So here we want to find dy dt. So we've got tan t plus cot t. dy dt is going to be equal to, if you differentiate tan t, you're going to get a 6 squared t. So from the MF19, we get that the differential of cot t is negative cos x squared t. And so now we've got both dx dt as well as dy dt. But remember, we want to find dy dx. So we're going to have to use these two rates of change essentially to come up with dy dx. So we have to create some sort of chain rule. So dy dx is going to be equal to dy dt multiplied by, here we actually want to use the reciprocal of dx dt, so we want dt dx, because that way essentially it cancels out and we still have dy dx. Okay, so dy dx is equal to our dy dt, which is sec squared t minus cos x squared t. So sec squared t minus cos x squared t, and this is being multiplied by, here we're multiplying by dt dx, but we found dx dt. So what we can do is we can flip dx dt so that we've got dt dx, and what you do on one side, you're going to have to do on the other side. Since we've flipped this side, we also have to flip it on this side. Remember that this is just the same as dividing by 1. So if we flip it, the 1 comes to the numerator, and we've got 1 over 6 cos 2t. Okay, so that's 1 over 6 cos 2t. So dy dx is equal to that 6 squared t minus cos x squared t, and this is over 6 cos 2t. Okay, so for now, let's just focus on our numerator. We can rewrite the 6 squared t can be written as 1 over cos squared t minus cos x squared t can be written as 1 over sine squared t. So in other words, we can combine our numerator to become sine squared t minus cos squared t over our common denominator, which would be sine squared t cos squared t. And notice how this part is quite similar to cos 2x is identical to cos squared. In fact, let me use t so that it's even more apparent. So cos 2t would be identical to cos squared t minus sine squared t. So essentially, if we factored out a negative sign in that numerator, we'd have negative cos squared t minus sine squared t. All right. And so it means that there, and this is O over our sine squared t cos squared t. So we can replace this part with cos 2t. So that what we have is negative cos 2t, and this is over sine squared t cos squared t. All right, let's just put it back into our dy dx for now. So dy dx is equal to, remember this is our numerator, that's negative cos 2t, and this is over sine squared t cos squared t, and this is O over 6 cos 2t. So dy dx is equal to, that's negative cos 2t, and this is over 6 cos 2t multiplied by that sine squared t cos squared t. So cos 2t cancels out, and we have that, we'll continue it down here. We have that dy dx is equal to, that's negative 1 over 6 sine squared t cos squared t. Okay, on the denominator, essentially what we're trying to get is a sine squared 2t. And what we have here is sine squared t cos squared t. So we want an identity that links sine 2t with sine t cos t. And the only identity I can think of is sine 2t is identical to 2 sine t cos t. So it means essentially we want to make this the subject of the formula, because if I come back here, dy dx is equal to negative 1 over 6. We can write sine squared t cos squared t as sine t cos t, and all of this is squared. Okay, so if we make it subject of the formula here, that's sine t cos t, and this is equal to sine 2t over 2. So we've just divided both sides by 2. Okay, dy dx is equal to, this is negative 1 over 6 multiplied by sine 2t over 2, and this is squared. So dy dx is equal to negative 1 over 6 multiplied by square the numerator, that's sine squared 2t, square the denominator, that's 4. And so what we end up with here is dy dx is equal to, this is negative 1 over 6 over 4 sine squared 2t, which essentially just becomes dy dx is equal to negative 4 over 6 sine squared 2t, which cancels out to, therefore dy dx is equal to negative 2 over 3 sine squared 2t, which is exactly what they are looking for. Okay. Now part B goes on to say, find the equation of the normal to the curve at the point where t is equal to a quarter pi. Give your answer in the form py plus qx plus r is equal to 0, where p, q, and r are integers. So to be able to find the equation of a normal, we need two things, because remember the normal is still a straight line. So we need the gradient of our normal as well as a point that lies on the normal. So since we want the normal at the point where t is a quarter pi, we can go to our parametric equation so that we can get our x and y coordinates. We're saying at t is a quarter pi, our x is going to be equal to 3 sine 2 times a quarter pi. So x is equal to, punch that into the calculator, that's 3 sine 2 times a quarter pi. Make sure that your calculator is in radians, and you should get a 3. And then for y, that's going to be tan a quarter pi plus quart a quarter pi, quarter pi. Y is equal to, so that's tan a quarter pi. And you can enter quart a quarter pi as 1 over tan of a quarter pi. And so this gives us y is 2. So we've got the coordinates as 3, 2. All right. So let's come back down here. So we know that our normal passes through the point. Is it 3, 2, or 2, 3? 3, 2. Okay. We know that our normal passes through the point 3, 2. Now what we need to find is the gradient at t is equal to quarter pi. So using dy dx, we're going to get the gradient of the tangent. And once we have the gradient of the tangent, we can essentially take its negative reciprocal because we know that the tangent is perpendicular to the normal. So in other words, m1 times m2 is negative 1. So our dy dx, we know that is negative 2 over 3 sine squared 2t, but we want to do this at t is equal to a quarter pi. So that means dy dx is going to be negative 2 over 3 sine squared 2 times a quarter pi. So dy dx is equal to, this is negative 2 over 3 sine 2 times a quarter pi. And this is squared. So that's negative 2/3. So we get that dy dx is negative 2/3. Remember, this is gradient of the tangent. We want the gradient of the normal. So that's just the negative reciprocal. So mn is going to be, just flip the fraction and change the sign. So 3 over 2. Now that we've got both a point that lies on the line as well as its gradient, we can go ahead and find the equation. They want it in the form py plus qx plus r equals 0. Okay, let's use point slope form. So y minus y1 is equal to m times x minus x1. So y minus 2 is equal to m, which is 3 over 2, times x minus x1, which is 3. And now let's multiply both sides by 2. So you're going to get 2y minus 4 is equal to 3x minus 3. So 2y minus 4 is equal to 3x minus 9. And let's move all these terms to the left. So that is 2y minus 3x minus 4 plus 9 is equal to 0. So 2y minus 3x, then that's 9 minus 4, so plus 5 is equal to 0, is going to be our final answer. Number 8, part A. Number 8, let f of x equal 7a squared over a minus 2x times 3a plus x, where a is a positive constant. Part A, express f of x in partial fractions. So we've got 7a squared over a minus 2x times 3a plus x, and this is equal to, that's going to be a over, because these are both linear factors, so a over a minus 2x plus b over 3a plus x, multiply through by a minus 2x times 3a plus x to get rid of all our denominators. So we've got 7a squared is equal to a times 3a plus x plus b times a minus 2x. All right, and then here we can say let x equal to, we want to evaluate a first, so we need to get rid of this bracket. So we need the x value that makes this bracket equal to 0. So a minus 2x is equal to 0, and we solve for x, so 2x equals a, x is equal to a over 2. So that means if we've got x as a over 2, this bracket will be equal to 0, so we can evaluate a. So this becomes 7a squared is equal to a times 3a plus x, which is a over 2, a over 2. So 7a squared is equal to, That's, we've got 3 plus 1 over 2. 3 plus 1 over 2, that gives us 7 over 2a. Be careful with the a's here. We've got the small letter a and the capital A. And so just multiply both sides by 2 over 7a. So by 2 over 7a, and we get that a is equal to, the a cancels that a, and then 7, 7, so a is 2a. And now we want to evaluate b instead, so we want the x value that makes that bracket 0. So 3a plus x is equal to 0, so x must be equal to negative 3a. So we can say let x equal negative 3a, and so you get that 7a squared is equal to, remember we're evaluating b because this becomes 0, so b times a minus 2 times negative 3a, so 7a squared is equal to, this is b, then here I've got a minus 2 times minus 3a, that's positive 6a, so I've got 6a plus a, which is 7a, and we can divide both sides by 7a. We get that b is equal to just a. All right, so this means that f of x in its partial fractions can be represented as 2a divided by a minus 2x, and then plus a over, what was that, the bracket, 3a plus x, 3a plus x. All right, and that will be our final answer. Part B says, hence obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. So we're going to use our partial fractions. So f of x is equal to, and what I'm going to do is 2a. I want to bring the a minus 2x up to the numerator. So it becomes a minus 2x to the power negative 1 plus a. And I'll do the same here. I want to bring the 3a plus x to the numerator. So it becomes 3a plus x to the negative 1. So let's start by focusing on the expansion of this. This is going to be 2a, and this is multiplying our a minus 2x to the minus 1. Remember, for us to be able to expand, this has to be the form 1 plus x, where x is some function of x to the power n. But we need to see this 1. So it means we need to factor out this a that we have over here. So it becomes 2a, and I'm going to factor out a, so that we've got 1 minus 2 over ax, and this is all to the power negative 1. So now I'm going to distribute the power, so that is a to the negative 1 times 1 minus 2 over ax to the negative 1. So we've got 2a times a to the negative 1 times our bracket 1 minus 2 over ax to the negative 1. So here a to the negative 1 is 1 over a, so that would cancel out and you end up with just a 2 outside there. So 1 minus 2 over ax to the negative 1. And now, since we have it in the form 1 plus some function of x to the n, we can use our formula for binomial expansion. All right, remember we're going up to the term in x squared. So that's 1 plus nx. N is negative 1. Our x is negative 2 over ax. Negative 2 over ax plus n, which is negative 1, n minus 1 over 2 factorial, multiplied by x, which is our negative 2 over ax, and this is squared. So we get that this is 2, we've got our 1, it becomes positive 2 over ax. Then let's figure out what the coefficient of x squared is. So that's negative 1 times negative 1 minus 1 over 2 factorial. All right, so this part just simplifies to 1. So let's focus on this part now. We've got the power 2, so square the negative 2, you get a 4. Square the a, you get a squared. square the x, you get x squared. Okay. And now let's just fully expand. This means that 2 times 1 minus 2 over ax to the negative 1 must be equal to, that's 2 times 1, so 2 plus 2 times 2 over ax, which is 4 over ax. Then we've got 2 times 4 over a squared x squared, which is 8 over a squared x squared. All right, so that's the expansion for the first term. We also need to find the expansion for our second term. We can do that on the side. So this is a times 3a plus x to the negative 1. Again here, we want to see this 1. So we're going to have to factor out this 3a. So it becomes a, factor out the 3a, so that's 1 plus x over 3a. And this is all to the power negative 1. Distribute the power negative 1 so that this is a times 3a to the negative 1 times 1 plus x over 3a to the power negative 1. So 1 plus x over 3a to the power negative 1. All right, and this 3a to the negative 1 is the same as 1 over 3a. Okay, and this is multiplying on 1 plus x over 3a to the negative 1. And these a's cancel out, and we essentially have a third multiplying outside 1 plus x over 3a to the negative 1. Now that we can clearly see our 1, we can go ahead and expand. So this is 1 over 3, and it's going to be 1 plus n. Our n is negative 1, and our x is x over 3a. So x over 3a plus n minus 1 over 2 factorial multiplied by our x, and this is squared. Okay, so this means that this is a third, this is 1, then this becomes negative x over 3a, and then here this will simplify to give a 1, so we need to focus on this part. So it's going to be square the x, you get x squared. Square the 3, you get 9. Square the a, you get a squared. Okay, so multiply through by a third. That's a third minus, that's x over 9a. And we've got a third times 9. That's 3 times 9, 27. So that's plus x squared over 27a squared. Okay, so this would be the expansion for our, essentially this is a over 3a plus x to the negative 1. All right, let me bring it closer to the other expansion so that we can consolidate. Okay, so it should mean that f of x is going to be equal to, let's start with our constants. So we've got 2 plus a third, and then the terms in x, we've got 4 over ax minus, what is that? Is that a 9? My word. I should write my numbers properly. Yes, this is a 9a. So that's minus x over 9a. And then the term in x squared. So that's plus 8 over a squared, x squared. And then we've got plus x squared over 27a squared. All right, so we get that f of x is equal to, we've got 2 plus a third. 2 plus a third gives us 7 thirds. So 7 thirds. And then here we've got 4 over ax minus x over 9a. So let's put them over a common denominator. So that's plus, that being divided by 9a. And so it means that this is 4 times 9. What's 4 times 9? That's 36. So we've got 36, and that's minus 1, and all of this is the coefficient of x. And then we're going to do something similar for our x squared. I believe this is an a squared. Yes, it is an a squared. So our common denominator here is going to be this 27a squared. Let's just zoom in here a little bit so we can see 27a squared. And so from here, we're going to get 8 times 27. 8 times 27, that's 216. Plus, and from here is just 1. And all of this is the coefficient of x squared. So it means that f of x must be equal to, the constant is fine, it's 7 over 3. Then here we've got 36 minus 1, so that's 35. And this is over 9ax. And then here we've got 216 plus 1. So that's plus 217 over 27a squared. And this is x squared. Can we simplify any of this further? No. 217 over 27. And so this would be the expansion of f of x up to and including the term in x squared. And then part C says state the set of values of x for which the expansion in part A is valid. Okay, so what you have to look for, remember that the expansion of 1 plus x to the n is valid for x is between -1 and 1. Right, so in our expansion, we have used 2 over ax. You use the expression where it's in the form 1 plus x, and you want to use your x here. Our x in this case was 2 over ax. So essentially we're saying that 2 over ax must be less than 1. And there's another one we used where they both 2 over ax. On this side we used x over 3a. So on this side, we used x over 3a. So the modulus of x over 3a should be less than 1. Maybe let's stop using modulus because it might be a bit difficult to see. So you know that the modulus of x is less than 1 is the same as x is between -1 and 1, or at least you should know that. So that means we can rewrite this as, this is 2 over ax, and this should be between -1 and 1. So we can multiply through by a over 2, so that we've got -a over 2 is less than x, which is less than a over 2. And then if we do the same here, that is essentially x over 3a is between -1 and 1. So that's going to be, if we multiply through by 3a, that's -3a. This is less than x, which is less than 3a. So here your solution would be this one, because you want the region that satisfies both. If I'm to draw a number line here and assume 0 is over here, this is 0, then let's say a is somewhere here, it means 2a would be somewhere here, and 3a is somewhere here. So in the other direction, we've got -a, -2a, and -3a. So this first region, that's -a over 2, I'll put it in red. So that's somewhere here, -a over 2, all the way up to a over 2. That's going to be somewhere here. All right. And then the other region, I'll put it in green, is from -3a all the way up to 3a. So that's going to be all the way, right, up to here. And we want the region that satisfies both of these inequalities, and that's just going to be our red region over here. So that's the one we take as our solution here. And you could see the answer being given in terms of modulus. They would give this as the modulus of x is less than a over 2. These are both the same. Number 9, part A. Find the quotient and remainder when x to the 4 plus 16 is divided by x squared plus 4. Okay, so we are dividing by x squared plus 4, and what we are dividing is x to the 4 plus 16 plus 16. All right, so we're going to say x squared into x to the 4. That gives us x squared minus x squared times x squared, that's x to the 4, x squared times 4, that's 4x squared, x squared. Now let's subtract, so x to the 4 minus x to the 4 gives us a 0. Then we've got minus 4x squared, so minus 4x squared. And then we can bring down the 16, so plus 16. And we can say x squared into negative 4x squared, that's going to give us a negative 4, minus 4 times x squared, so that's minus 4x squared, minus 4 times 4, that's minus 16. And we've got minus 4x squared minus 4x squared, which is 0. Then we've got 16 minus 16, so that's 16 plus 16, which is 32. And at this point, we can't continue to divide because the highest power in our divisor is now higher than in our dividend. So this becomes our remainder and this becomes our quotient. So you can say that therefore quotient is x squared minus 4. Remainder is 32. Part B says, hence show that the integral from 2 to 2 root 3 of x to the 4 plus 16 over x squared plus 4 with respect to x is equal to 4/3 pi plus 4. Okay, so x to the 4 plus 16 over x squared plus 4. This is the same as saying x squared plus 4 is dividing x to the 4 plus 16. And we got that this gives us a quotient of, our quotient is x squared minus 4, because this is exactly the same as what we've just divided here. We get x squared minus 4. So this becomes our quotient, x squared minus 4, plus our remainder, 32, over the divisor, x squared plus 4. All right, so we're saying that this here can be rewritten as x squared minus 4 plus 32 over x squared plus 4. So instead of integrating this, we can integrate this instead. So that's the integral from 2 all the way up to 2 root 3 of x squared minus 4 plus 32 over x squared plus 4. And this is with respect to x. In fact, I'll just write the 4 as 2 squared. I'll explain it in a second. 2 squared. So now let's integrate. If you integrate x squared, you're going to get x cubed over 3 minus, if you integrate 4, you're going to get 4x. And then here we want to use the idea that the integral of 1 over x squared plus a squared with respect to x is equal to 1 over a arctan of x over a. So in our case, the 2 would be the a and x is x. Then since we've got 32, the 32 would essentially just be multiplying everything. So it would be 32 over our a, which is 2, arctan of x over a, so x over 2. And this is from 2 all the way up to 2 root 3. So let's simplify. This is x cubed over 3 minus 4x. 32 over 32 over 2 is 16, so 16 arctan of x over 2. And our limits are from 2 to 2 root 3. Right, so let's substitute in our limits. Starting with the upper limit, that's going to be 2 root 3 cubed over 3 minus 4 times 2 root 3 plus 16 arctan of 2 root 3 over 2. All right, and then the lower limit, that is going to be 2 cubed over 3 minus 4 times 2 plus 16 arctan of, that's 2 over 2. All right, now let's simplify. So here we've got, that is 2 root 3, and this is cubed over 3. That gives us 8 root 3. So we've got 8 root 3. Then this is minus 8 root 3. And we've got plus 16. Let's find arctan of root 3. Arctan of root 3 is a third pi. So it's plus 16 multiplied by a third pi minus, now let's do it for the lower limit. So 2 cubed is 8, so that's 8 over 3 minus 8. Then we've got 16 arctan of 1. Arctan of 1 is a quarter pi. So we get 16 multiplied by a quarter pi. Okay, so let's simplify. 8 root 3 minus 8 root 3 cancels out. Then we've got 16 over 3 pi minus, here we've got 8 thirds minus 8, which gives us negative 16 thirds. Then we've got 16 times a quarter pi, so that's 4 pi. So that's 16 over 3 pi plus 16 over 3 minus 4 pi. So what we have is, that's 16 pi over 3 minus 4 pi plus 16 over 3. And what do they factor out? Do they factor out a 16? They factored out 4 thirds. Okay, first let's simplify our like terms here. That's 16 over 3 minus 4. That's going to give us 4 thirds pi plus 16 thirds. And then we can factor out 4 thirds. That's going to be pi plus 16 over 3 divided by 4 thirds. That's 4. And this is our final answer, which is exactly what they have. Number 10, a water tank is in the shape of a cuboid with a base area of 40,000 square centimeters. At time t minutes, the depth of the water in the tank is h centimeters. Water is pumped into the tank at a rate of 50,000 cubic centimeters per minute. Water is leaking out of the tank through a hole in the bottom at a rate of 600 h centimeters cubed per minute. Show that 200, part A, show that 200 dH dt is equal to 250 minus 3h. Alright, so if I can draw the diagram of what we're looking at, it probably looks something like this. So we've got the base here, and then we also want to have, I would draw the top part somewhere here, like that, and then just join our lines. So that's going to be that, and that's going to be that. Okay, so this is our cuboid, and we're told that the base area of our cuboid is equal to 40,000 square centimeters. All right, at time t minutes, the depth of the water in the tank is h centimeters. Okay, water is pumped into the tank at a rate of 50,000 cubic centimeters per unit. So here, what this means is that the volume is changing, so it's dV dt. And a hint will be your unit. Because you can see that this is cm cubed is volume per minute, so that's with respect to time. That's why it's dV dt. Okay, and water is being pumped into the tank at a rate of, so the volume is increasing by 50,000 per minute. Water is leaking out of the tank through a hole in the bottom at a rate of, let me just erase this, Again, our units here are still cm cubed per minute, so it means we're still dealing with dV dt. And because water is leaking, this is a decrease in our rate, and this is by 600 H. 600 H. Okay, and we are told to show that, so we want dH dt essentially. The way we can do that is we've got dV dt. We can also come up with another rate of change so that we can construct a chain rule to get us dH dt. So the reason they've given us the area is because they want us to use the volume of the cuboid to help us in this question. So the volume is going to be equal to the base area multiplied by the height, h, of the water. All right, so base area times h. So essentially V is 40,000 h. So using this equation for volume, we can find dV dH. And that's just going to be 40,000. As a result, we can now construct a chain rule for dH dt and say that dH dt is equal to, we want dH in the numerator. So from these two, where do we have a dH? The dH is in dV dH, but we're going to want to use dH dV instead because we want dH in the numerator. And so what happens here is you're going to have to flip this because you flipped this side. So that's 1 over 40k. So this is dH dV, and this is multiplied by our dV dt here. So technically this would cancel out to give us dH dt. So the chain rule is correct. So dH dt is equal to dH dV, which we said is 1 over 40k. 1 over 40k, 40,000, multiplied by dV dt. dV dt is 50,000 minus 600 H. Okay. And so dH dt is equal to, this is 50,000 minus 600 H, and all of this is over 40,000. All right, and let's compare to what they have. So from what I can see, if we write this as dH dt, right, make dH dt subject of the formula, this would be 250 minus 3h, 3h over 200. So what it means is that we should factor out a 200 in both the numerator and the denominator and cancel it out. So dH dt is equal to, we can factor out 200. So 50k divided by 200, 1, 2, 3 over 200, that gives us 250, minus 600 divided by 200, that's 3, and this is over 40k divided by 200, that gives us 200. So we've got 200 times 200 here. And so this would cancel out, and you end up with dH dt is equal to 250 minus 3h. And this is over 200. Multiply both sides by 200. You get that 200 dH dt is equal to, that's 250 minus 3h. And this would be our proof. Part B, it is given that when T0, H is equal to 50, find the time taken for the depth of the water in the tank to reach 80 centimeters. Give your answer correct to two significant figures. So in other words, they are saying solve your differential equation and then find T when H is equal to 80. All right. So what's our differential equation? We've got 200 dH dt is equal to 250 minus 3h. Okay. So we need to separate our variables. We can move dt to the right hand side so that it's 200, and then this is coming that way, this is going that way. So 200 over 250 minus 3h dh is equal to just dt. And so we can integrate both sides. This is just integrating 1. So if we integrate here, we've got the 200 on the numerator. So 200 divided by negative 3 ln 250 minus 3h. What we've used is the integral of 1 over ax plus b with respect to x is equal to 1 over a ln ax plus b. Okay. And then plus a constant of integration, and this is equal to, if you integrate 1 with respect to t, you get t. Okay. And to evaluate our constant of integration, we can use this information. T is 0 when h is 50. So that means negative 200 over 3 ln 250 minus 3 times 50 plus c is equal to 0. So here 250 minus 3 times 50, that's 150. So negative 200 over 3 ln 250 minus 150, that's 100. So 100 plus c is equal to 0. So c is equal to positive 200 over 3 ln 100. And so it means our solution to this differential equation is t is equal to, got this part here, that's negative 200 over 3 ln 250 minus 3h plus our constant of integration 200 over 3 ln 100. And so this is the solution for the differential equation. But remember, we said what the question wants is it wants to know, find the time taken. So it wants to know t when h is 80. So we need to substitute h with 80. So t is equal to negative 200 over 3 ln 250 minus 3 times 80 plus 200 over 3 ln 100. So t is equal to, let's punch that into the calculator, that's negative 200 over 3 ln 250 minus 3 times 80 plus 200 over 3 ln 100. And they want their answer correct to how many significant figures? They want 2 significant figures. So I've got 153.5, and to 2 significant figures, t is going to be 150. This question is interesting because typically when they want you to solve a differential equation, they will explicitly tell you to solve the differential equation. But here they've sort of disguised the question around and required you to find the time taken. So you'd have to realize that first I have to solve the differential equation and then I can evaluate t at h is 80. Anyways, number 11. The diagram shows the curve y is equal to 2 sine x square root 2 plus cos x for x is between 0 and 2 pi and its minimum point m where x is equal to a. Find the value of a correct to 2 decimal places. So we want to find the x coordinate at a minimum point. So the main idea here is going to be dy dx is equal to 0. We know that at a stationary point, the gradient is equal to 0. So what we need to do here is to find our dy dx. I'm just going to rewrite our y as 2 sine x times 2 plus cos x to the power of half. All right, so dy dx. Notice here that we've got 2 functions multiplying each other. So we need to use the product rule. And a simplified way of thinking about the product rule is you're going to hold the first function, so hold 2 sine x, and now differentiate the other function. So we need to differentiate 2 plus cos x to the half. Let's start by bringing the half down. So you've got half times 2 plus cos x. Subtract 1 from the power, so that's negative a half, multiplied by differentiate the inner function. So differentiate 2, you get 0. Differentiate cos x, you get negative sine x. Okay. Plus, now we're going to hold the 2 plus cos x to the half. So I'll write it here, 2 plus cos x to the half. And then you differentiate your 2 sine x. If you differentiate 2 sine x, you get 2 cos x. All right, so let's simplify here. We've got dy dx is equal to, and here you're going to get 2 and the half cancelling out. Then we've got sine x being multiplied by negative sine x, so negative sine squared x, sine squared x. And this is multiplying our 2 plus cos x to the negative half. 2 plus cos x to the negative half. All right, and this is plus, we've got our 2 cos x, 2 cos x times 2 plus cos x to the half. So I'm just going to rewrite this as dy dx is equal to negative sine squared x, and this is over our 2 plus cos x. This is to the power half, plus our 2 cos x times 2 plus cos x to the half. Factor out this denominator so that we've got dy dx is equal to, that's 1 over 2 plus cos x to the half. And this is being multiplied by, the first term becomes negative sine squared x. And then here we've got plus 2 cos x. So that's times our 2 plus cos x to the half, to the half. So because we're factoring out 1 over 2 plus cos x to the half, this would be the same as dividing by 1 over 2 plus cos x to the half. And that's just the same as multiplying by 2 plus cos x to the half. So I'll bring it to the numerator. And we're multiplying by 2 plus cos x to the half. And we can close our big bracket. So we've got dy dx is equal to 1 over our 2 plus cos x to the half. And this is multiplied by our negative sine squared x. And then here what's going to happen, notice that we've got the same base here and the multiplying. So what we simply do is to add the powers. Half plus half gives us 1. So that becomes plus 2 cos x multiplied by 2 plus cos x to the power 1. So let's write this on the side. We are getting that our dy dx is equal to 1 over 2 plus cos x to the half multiplied by our negative sine squared x, negative sine squared x. And then here we can expand. We've got 2 cos x times 2, which gives us 4 cos x plus 4 cos x. And then we've got 2 cos x times cos x, which is 2 cos squared x. So that's plus 2 cos squared x. Alright, so at this point, I'm now going to equate to 0 because remember, at the end of the day, we want to find our minimum point, and we know that at a minimum point, the gradient is 0. So this becomes 1 over 2 plus cos x to the half multiplied by negative sine squared x plus 4 cos x plus 2 cos squared x, and this is all equal to 0. So this means either this part is 0 or this whole parenthesis is 0. So we can have either 1 over 2 plus cos x to the half is equal to 0, or negative sine squared x plus 4 cos x plus 2 cos squared x is equal to 0. And with the first equation here, we're going to get x is no solutions because we can't solve that. And then in the second equation here, we can use an identity to rewrite our sine squared x in terms of cos squared x so that we end up with a quadratic in cos x. So we want to use the identity that sine squared x is identical to 1 minus cos squared x. So that this becomes negative 1 minus cos squared x plus 4 cos x plus 2 cos squared x. And this is equal to 0. And so what we have is negative 1 plus cos squared x plus 4 cos x plus 2 cos squared x is equal to 0. Let's add the like terms. So we've got cos squared x plus 2 cos squared x, that's 3 cos squared x. We've got plus 4 cos x. We've got minus 1 is equal to 0. So we've got a quadratic in cos x. Alright, so let's use the quadratic formula here to solve. So that's minus 4 plus or minus the square root of minus b squared, or just b squared, 4 squared minus 4a, which is 3 times c, and this is O over, that's 2 times a, so 2 times 3. So cos x is equal to, that's negative 4, negative square root 4 squared, negative 4 times 3 times negative 1, and this is over 2 times 3. So negative 2 plus or minus the square root of 7, and this is O over 3. So we're getting that either cos x is equal to negative 2 negative root 7 over 3, or that cos x is equal to negative 2 plus root 7 over 3. Okay, so x is equal to, that's arc cos of negative 2 negative root 7 over 3. That should be root 7 over 3. And what units are we using? Are we in degrees? Are we in radians? We are in radians. Okay, in radians. So make sure your calculator is in radians. We want to evaluate arc cos of negative 2 negative root 7 over 3. And this is gonna give us an error. So x is no solutions here. And my guess is that this value in here is probably less than negative 1. It's negative 2 negative root 7 over 3. That gives us, exactly, it gives us negative 1.548 and so on. And the idea is that if I am to draw our equation of y is equal to cos x, just ignore the bent x's. The point is we're looking at something like this, and this here is going to be 1, this is going to be negative 1. Let me just extend it downwards a little bit. The point is this line, negative 1.548, is somewhere here. That's negative 1.548. And if we draw a line going through, we can tell that this does not intersect y is equal to cos x. So it means that this equation at the top cannot have any solutions. Because remember, the number of solutions is simply the number of points of intersection. Okay. And on this equation, we get that x is arc cos of negative 2 plus root 7 over 3. So x is equal to, that's arc cos of negative 2 plus root 7 over 3. And this is equal to, this is 1.353848056. And if I remember correctly, on our diagram, it appeared we had 2 stationary points. Okay. So yes, this 1 point, whatever we have, 1.353, 1.3538 is going to be this stationary point. Okay. The reason we know that is because it's less than pi. Pi is approximately 3.14159 and so on. All right. We need to find the x coordinate at this point. All right. So let's go back to our problem and let's see if we can figure out what the value of that stationary point is. So there are many ways we can solve this, right? We can consider this value to be our principal value, and we can sketch a diagram. This is y is cos x. So we are looking at, or essentially, I'm not going to redraw it. We have it on the side. We will not have time to be drawing things too many times in the exam. Anyways, the point is we have found x is 1.35. So this is the x-axis. X is 1.35. This here would be pi over 2. That's pi. So that's 3 pi over 2. And this here is going to be 2 pi. And we want 1.35. Pi over 2 is approximately 1.57 and so on. So we found the value at 1.35, which will probably be somewhere here. Okay. And if we draw a straight line going through, we can tell that we should have another solution somewhere here. And by symmetry, the distance here should be equal to the distance here. So essentially, to get this point, we can say that it's just 2 pi minus our value here, minus 1.353848. And so what does that give us? This is 2 pi minus 1.353848. That's 4.929. Alternatively, you can use the formula PV plus, this is in radians, so 2 pi n is plus or minus. And in this case, you'd evaluate at n is equal to 1. That's where your solution is. And say minus PV is the one with the solution plus 2 pi times 1. Because that's essentially just 2 pi minus PV, which is exactly what we have here. All right. So it means our answer should be 4.929, and we can just check with a diagram to see if it checks out. So we know that it's definitely greater than pi, because pi is 3 point something, and it's less than 2 pi. 2 pi is 6.28 approximately. So we've got 4 points. So it checks out that m should be around 4. So we can, or rather a, which is the x coordinate at m. So we can conclude that x is, or rather a, let me not write it as x because they asked us to find a, not x. So this means that our a is equal to 4 point, how many decimal places? 2, so 4.93. All right, because we had 4.929, so 4.93. That would be our final answer. Part B says use the substitution u is equal to 2 plus cos x to find the area of the exact area of the shaded region R. Okay, so what this means is that we are integrating our curve from 0 all the way up to pi. So 0 to pi, and our function is 2 sine x times square root 2 plus cos x. So 2 sine x times square root 2 plus cos x with respect to x, using the substitution u is equal to 2 plus cos x. Okay. So the first thing we want to do is to substitute our limits. So we know that at x is equal to 0, if we substitute it using our substitution, it becomes 2 plus cos 0. Be careful, because 0 is not 0, because 0 is 1. So this becomes 2 plus 1, and u is equal to 3. And then at x is equal to pi, we get u is equal to 2 plus, that's cos pi. Cos pi is negative 1, so 2 minus 1, u is equal to 1. So it means our new limits now, we're integrating from the lower limit was x is 0. So you're going to switch it exactly as it was. So where we had 0, we now have 3. And where we had pi, we now have 1. And this is 2 sine x root 2 plus cos x. Now, obviously, our limits are in the wrong order. So if we want to correct them such that the lower limit is the smaller limit, we're going to have to multiply our integrand here by a negative 1. So it becomes, I'll put the negative sign outside negative, and then you can flip your limits to 1, 3. This is 2 sine x times root 2 plus cos x with respect to x. Now, the next thing we want to do is we want to substitute our dx. So to do that, we're going to have to differentiate our substitution. So du dx is equal to, if you differentiate a constant, you get 0. Differentiate cos x, you get negative sine x. And so that means dx is going to be equal to, that's du over negative sine x. And so it means we've got negative the integral from 1 to 3 of 2 sine x multiplied by root 2 plus cos x. And we're replacing our dx with du over negative sine x. So du over negative sine x. Notice how these negative signs cancel out and the sine x cancels out. Okay. And so now I'm just going to take this 2 outside the integral sign. So we've got 2, the integral from 1 to 3 of root 2 plus cos x. And this is with respect to u. And u we know to be 2 plus cos x. So if u is 2 plus cos x, we can just replace this part with u. So that 2, the integral from 1 to 3 of the square root of u with respect to u, and now everything is in terms of u. I'll just rewrite that as u to the half so that we can integrate it. Du, and now we can go ahead and integrate. Add 1, that's u to the 3 over 2, and then divide by 3 over 2, which is multiplying by 2/3. And this is from 1 all the way up to 3. So let's substitute in our limits. We'll do it on the side. So that's 2. We'll start with the upper limit. So that's 2/3 times 3 to the power 3 over 2. And then we've got minus. And in this case, it's 2/3 times 1 to the power 3 over 2. Okay. So here, if we punch it into the calculator, some calculators might be able to compute this and give you an exact value, but mine can't. So I'll show you how we can manipulate our surds there to simplify it. So we've got 3 to the 3 over 2, which I can write as 3 cubed times to the power half, because 3 times half is still 3 over 2. Okay, and we know that 3 cubed is going to be 27. So this is 27 to the half, which is just root 27. And we can write this as root 9 times 3. So root 9 times 3 can be split. You can split your square root sign so that it's square root 9 times square root 3. This only works for multiplication. Do not try this for addition. It does not work that way. Okay. And then square root 9 is 3. So that's just 3 root 3. So it means we can replace this part with 3 root 3. So that we've got 2 times 2 over 3 times 3 root 3. And this is minus, this part will be 1, so it's just minus 2/3. But 2 times the 3's cancel out, so that's 2 root 3 minus 2 over 3. And if we multiply through by 2, that's 4 root 3 minus 4 over 3. And this is the exact area of our shaded region R. Okay, so that will be the final answer, and that will be the paper as well. I mean, genuinely, these paper threes for October, November 2024 were just something else. So I mean, kudos to you if you did well in them, man. But anyways, if you found this video useful, please share it with others who you think would also find the video useful, and make sure to leave a like, subscribe, and comment down below what paper would you like to see me solve next. Bye bye.